Okay, let's do this. So that 3, 8, -9 belongs to the subspace R3 spanned by 1, 2, 3, and 2, 5, -3 by writing it as a linear combination of the spanning vectors. Coffee burp. All right. What is this asking? It's asking us, a linear combination is where linear combinations are adding vectors together or multiplying vectors by scalars. A scalar is just a number. So we have two scalars. We want to see if this, let me write it the way that I'm thinking. We want to see if 3, 8, -9, if we can get this from a linear combination, which is a scalar times a vector plus another scalar times another vector. That's what we want to see. We want to see what the S1 and S2 are. There's a lot of different ways that you can do this. In order for this to work, these vectors have to, all three of these vectors have to belong to a subspace of R3. Because normally in order to get like an answer like this, you need three vectors that are all linearly independent, right? If they're linearly independent, three polynomials or whatever, then you can't do this. However, in this case, it says show that it does belong to it. So I'm guessing that two of these at least are linearly dependent on each other, and that's why they form a subspace. So it's just a lot of mumbo jumbo. Essentially, two of these are like either multiples of each other or they share roots or something like that. Okay. So the way I like to do this is just to write out the whole thing as a system of linear equations. So essentially just taking it out of the matrix form and putting it into the standard algebra form. I'm sure that there's like a way of writing it in matrix form that you can just go through and solve. All right, so I need to eliminate one of these variables. It looks like I could take this first one, multiply it by -2, and add it to the second one to get a new matrix. So let's just multiply -2 through this. So -2 times S1 is -2 S1. -2 times +2 is -4. -2 times 3 is -6. So since we multiplied 2 on both sides, it's still an equivalent expression. Now let's add it to this row. Okay. So -2 S1 plus 2 S1 is just 0. S1, which is just 0. Plus -4 S2 plus 5 S2 equals 1 S2, or just S2. 8 minus 6 is just 2. So we figured out what S2 is. S2 equals 2. Now let's plug S2 back into one of these other equations. Let's just do the bottom one. So 3S1 minus 3 times 2 equals -9. This is -6. To get rid of -6, we have to just add 6 to both sides. That's going to cancel that out. And so we get 3S1 equals -3. Divide both sides by 3 to get rid of the 3 on this side. We get -3 over 3, or -1. Okay, and that's how I found out what S1 and S2 are. So I saved the solution. Let's see if we got it right. Paste. No, why are you doing this? There we go. Okay, S1. Yep, S1 is -1, S2 is 2. This is the correct answer.